Hello and welcome to another Portworx demo. My name is Pavan Shah and today we'll be talking about how we can deploy a Kafka instance using Portworx Data Services with a backend Zookeeper instance as well. So both Kafka and Zookeeper are data services that are supported by Portworx Data Services today, and you can deploy both on any Kubernetes cluster that you have already added to your Portworx database data service instance or the SaaS control plane. Let's start by talking about how you can deploy a Zookeeper instance. So let's give our Zookeeper instance a name. So we'll just call it zk-pds-demo. We'll select an EKS cluster as our target cluster and then select a namespace on that cluster that has been configured for Zookeeper, which is just called zookeeper-demo. Once we select that namespace, we can also configure optionally the load balancer instances that will be used by our Kafka installation to talk to Zookeeper. We'll keep the application configuration settings to default and resource settings at small. We don't allow you to modify the number of nodes in a Zookeeper instance, so that's just 3 nodes for your Zookeeper deployment, and then you can configure the backend storage you need for Zookeeper using the drop-down menu. This initiates the process of PDS talking to the PDS agent that's running on your EKS cluster and initiating the deployment of the Zookeeper instance. So it involves creating a stateful set, the persistent volumes that will be used by Zookeeper, service endpoints that will be used to communicate to the Zookeeper instance by Kafka. Once all of that is configured, in the PDS UI, you will see that the status has been changed from deploying to running with all 3 nodes being active. You can click on view connections, and this is where you can get the connection points for any one of the Zookeeper nodes, and you can get the username and password that you can use while deploying Kafka. So now let's go ahead and go to the dashboard and create a new Kafka instance which uses Zookeeper as the backend as well. So let's give our Kafka instance a name. So we'll just call it Kafka-PDS-demo. We'll select the same EKS cluster that we selected for Zookeeper. We'll select a different namespace. So in this case, we are selecting the Kafka-demo namespace. And here, Portworx gives you the option of selecting either a Zookeeper backend for your Kafka instance or just use the Craft backend that's now also available using if you're running Kafka versions 3.0 or higher. So since we want to make this production grade, we will select small heap with external Zookeeper as our application configuration as the default that's available from Portworx. Here, as you can see, it asks me for the Zookeeper password and the connection string, and this is something that we copied in the earlier step once the Zookeeper installation was successful. Now for the size for Kafka instance, we'll select a small, and then we'll select 3 nodes or 3 brokers for my Kafka instance. We'll select any storage options that are available in the drop-down menu. Once we are happy with all the different settings that we have chosen, we can hit deploy, and Portworx Data Services initiates the Kafka deployment on your Amazon EKS cluster with the Zookeeper backend for its heap configuration that we selected earlier. So Zookeeper with Kafka enables a few different use cases. So the way these two things work together is Zookeeper is responsible for the controller election. So basically selecting which is the controller out of all the brokers that Kafka has. It also maintains a list of all the functioning brokers in the system. So it manages cluster membership. It maintains topic configuration. So maintains all the configuration of all topics, including list of existing topics, number of partitions that are enabled for each topic, location of the replicas, etc. It also has access control list information or ACLs for all the topics and quota information. So Zookeeper provides all of these functionality to your Kafka instance, and that's why you need it. Like that's how they have been working together in production for many customers. Now let's use the Kafka instance that we deployed and use it as part of an application, right? We don't have a producer consumer application, demo application for you. So what we are going to use is a free open source UI that's available for any Kafka instance and provide our connection string information to that UI. So when we navigate to the user interface dashboard, we look at the Kafka instance that has been deployed by PDS for us. In the YAML file, we will update a couple of environment variables that are being provided. We'll update the Bootstrap server information. So we'll copy the endpoint information from PDS dashboard and paste it in the YAML file. And then we'll also update the password that will be used by this Kafka UI to talk to our backend Kafka instance. As you can see, PDS uses the SASL authentication method. So it has a username called PDS and password that's being provided to you from the dashboard itself. So you don't have to go and exec into any specific pods and fetch that information. Once our YAML file is ready to go, we'll go ahead and apply that YAML file in our Kafka-demo namespace, and it creates a deployment object with a pod and a service object with an external load balancer instance. So once the external load balancer, the ELB load balancer, is up and running, we should be able to navigate to the UI and access our Kafka UI instance and look at our Kafka cluster. So let's do a kubectl get all. As you can see, our Kafka UI pod is already up and running. Our load balancer endpoint, we did get one assigned from Amazon. It's an ELB endpoint. So we'll take this, we'll copy this and then navigate to it using our browser. So here it takes a few seconds to a couple of minutes for the endpoint to be actually accessible. Once it is, we can see that we have our online clusters, which is the default cluster called local that's been deployed by PDS, running version 3.0. You can try to generate a list of topics and generate or produce messages to test that the Kafka instance is functional. So let's create a demo topic with one partition, 3 as a replication factor, and then hit create. And once that's available, we can produce messages. So the Kafka UI has a cool functionality where it allows you to generate a few messages to test your backend Kafka instance. So we will generate a couple of messages inside our topic and see that both of those are listed. If we go back to the list of brokers, you can see all the 3 nodes that we configured using the PDS UI. The same endpoints are now visible through the Kafka UI as well. So this is how easy it is to deploy a Kafka instance on any Kubernetes cluster that's supported by Portworx Data Services and start using it as part of your application. That's it for this demo. Thank you for watching.